Okay, so let's do number 6. So 6 is all types or value types, and all parameters are passed by reference, which means that all of the uh, formal parameters become essentially aliases for their actual parameters. Let's go ahead and start executing here. So we're executing this first call to G. So we are passing in M for A, which means at this point that A essentially has become a reference for M. So I'm just going to designate it like this. There are different ways that you could designate this as you're working through it because we're asking about output rather than drawing particular things here. I don't care how you denote this, but just some notion. You could also, if you wanted to, you could do our arrow notation and do something like that. But things are going to get messy if I do that for all this. So I'm just going to stick with the address of notation, which you should be familiar with from 261. In 261, we kind of use it to denote pointers. Here, I'm just going to sort of use a similar syntax to denote references. So what this means is that inside of G, um, A is essentially an alias for M. So any change that we make to A or any read that we make from A is going to happen through M. Same thing for B, it becomes a reference to X, and C becomes a reference to Y. Okay, so let's think about what each of these things does in turn and how they change things. So A sub B, so that's really M sub X, so that's M sub 0. That's going to get set to 0. So that's going to change this value right here. B is going to be incremented, so that's going to increment X. Um, After that, we're going to increment Y by B, which means that we are going to increment Y by X. So 1 plus 1 equals 2. And then the last thing that we're going to do is to set A sub C, so that's A sub or M sub Y. So that's the second thing here, so that's this 5. And we are going to set that to 8. So that's the change that's going to happen. So what that means is that when we get back to main now, and note that this is completely different than the last example, right? Because everything that we've been doing has been changing these program level variables. So this is going to be a significant difference. So the first 3 numbers that we're going to print are going to be M. So this is 0, 3, and 8. And then we're going to print X, which has changed to 1, and we're going to print Y, which has changed to 2. And I probably should have erased the addresses there because A, B, and C go away, but in fact, they're going to be very similar in the second call to G. So now we're looking at this call to G. And so the one difference here is that B is no longer going to be a reference to X. So because recall that we're now passing Y as the actual parameter for both B and C. So both of these are going to be references to Y, and this is why pass by reference and anything involving references starts to get kind of complicated to reason about it. It makes the program harder to understand because inside of G, B and C look like different things, but in fact they're aliased to the exact same value. They're both aliased to the Y from the program. Sorry, almost knocked something off my desk. Okay, so let's think about what happens here. So we have A sub B. So B is now Y. So that's going to change. A sub Y. So that's 2 to 0. So let me switch back to my blue. So that is going to change the 8 to a 0. Then we're going to increment B, and note at this point that B is a reference to Y, right? So we're going to increment Y by 1, so 3. And then we are going to increment, so this has incremented Y by 1, and now we're going to increment Y again by itself. And so this is why it's very confusing that B and C are both aliases for the same variable, because it looks like these two should be saving the results to different variables, but in fact they're the same variable, they're both y. So we're going to increment y by itself, which means that it changes from 3 to 6. Okay, so now we do a sub c, so c is y, so a sub 6. So that's going to change one of these values way out here, so 0, 1, 0, 1, 2, 3, 4, 5, 6. So that changes this very last one to 8. That's not going to have any effect on the print, but it might be important to note that that change has happened. All right, so what is the final output of the program? Um, so the final output of the program when we get back to main, so we're going to print the first three elements of M, which at this point are 0, 3, and 0. We're going to print X, which at this point is still 1. And then we're going to print y, which at this point, because of the two increment operations, is now going to be 6. So that is the result for problem number 6.